Hi, this is Michael King. Now we're going to look at a topic within time value of money where we're converting from quoted rates to effective rates. In Booth, Clear, and Rokita Chapter 5, this is actually section 5.6. And although it's a very short section with only a couple of pages, we're going to take some time to understand it because it can be quite confusing. So what we're going to do is we're going to convert from what is called a quoted rate to an effective rate. We're also going to convert from a quoted rate to a specific effective rate, which is an effective annual rate, or the equivalent of how much your money would grow over 1 year. We need to know how many times the compounding happens, which is going to be referred to by M, and the frequency of payments that are made in a year, which is going to be referred to as F. Finally, we're going to learn how to convert from one effective rate to another effective rate. So, for example, how can we convert from an effective annual rate to an effective monthly rate? So let's think of an example. Suppose you're offered a 1-year loan with a choice between two interest rates. Which one do you think is cheaper? You're offered 35% per annum or 2.6% charged each month. Well, the answer is that A is cheaper, because if you were to convert a quoted rate of 2.6% per month to an effective annual rate, you would find out it is over 36%. Now, we're going to need a formula to make this calculation, and we'll show you that in a moment. The point is that if you have compounding, you have to take that into account. You cannot compare apples and oranges. You have to compare rates that are compounded at the same frequency. Not all rates are actually quoted as annual rates. Many borrowers will actually charge interest rates either daily compounding, monthly, quarterly, or even semi-annually. So we need to be able to take these quoted rates that have different compounding frequencies and compare them so that we're looking at apples to apples. So what we're typically going to do is we're going to calculate what the effective annual rate is, taking into account different compounding periods. So let's say you purchase a house and you take out a mortgage for 30 years with a quoted rate of 5%. How much will your monthly payment be? This turns out to be quite a complicated problem. It's not easy to figure out, and the reason is that there's two things you need to know about mortgage rates. Mortgages in Canada use semi-annual compounding, so M is 2 times per year. And mortgages in Canada make monthly payments, so the frequency of payments is 12 per year. So we're going to need a formula to calculate from the quoted rate of 5% to an effective rate, so we can figure out your monthly payment. So the quoted rate is the rate that is advertised by a lender. It may be compounded annually, quarterly, monthly, or something else. In Canada, Canadian lenders are required to quote an annual percentage rate, or APR. Be very careful with this rate, because this rate, although it includes any fees that you'll be required to pay, including interest expense, any other lender fees, closing costs, etc., the APR is a simple interest rate. So going back to a couple sessions ago, we talked about simple interest rates versus compounded interest rates. The APR is a simple interest rate that does not take into account compounding. So what we want to do is we want to calculate a rate called an effective rate that takes into account compounding. So just to review, a quoted rate does not take into account compounding, and the APR, although it's annualized, also does not take into account compounding. So the effective rate is the rate at which a dollar invested will grow over a given period, say daily, monthly, or annual. So let's start by converting to an annual rate, or an effective annual rate, EAR, where we know that there is one compounding period per year. Sometimes this rate is called the annual percentage yield. Okay. Now the quoted rate and the effective annual rate will only equal each other when the quoted rate has one compounding period per year. So if they both have annual compounding, the quoted rate and the effective annual rate are the same. The problem comes in when quoted rates have more frequent compounding. So there's a formula for converting from a quoted rate to an effective annual rate. Here's the formula. K represents the effective rate. QR represents the quoted rate. M represents the frequency of compounding. So for daily it would be 365, for monthly it would be 12. F represents the number of payments that you need to make each year. If you're converting to an effective annual rate, you're only making one payment each year, so F is going to be equal to 1. Okay, so here's the formula. Let's try using it. So a typical credit card in Canada charges you a quoted rate of 20% per year, but it is compounded daily. So what would be the effective annual rate? Okay, so now here you can see we're using K with the subscript EAR. This is not how they refer to it in the book. In the book it's a little confusing. You don't know which effective rate you're looking for. So I've put in EAR here so that you know we're looking for the annual rate. Because it's an annual rate, we're going from daily compounding on this quoted rate. So M is going to be equal to 365. Because it's an effective annual rate, F is going to be equal to 1 because we're trying to figure out what one payment per year would be. So plugging in the quoted rate of 20%, dividing it by 365 days per year, you take 1 plus that, you raise it to the power of 365 divided by the frequency of payments in the year, which is 1. Subtracting 1 from that, you get 0.2213 or 22.13%. In other words, a quoted rate of 20% with daily compounding is actually equal to an effective annual rate of 22.13%. So this is an example of how lenders are able to advertise a rate which appears to be lower than it actually is. So let's look at another example. We have a quoted rate of 20%. This time, instead of compounded daily, it's compounded quarterly. What is your effective annual rate? Okay, so what this means when it says that it's compounded quarterly is effectively what that means. You're going to be basically paying 5% on your money each quarter, and the money is going to grow each quarter. So the interest at the end of the first quarter is going to be accumulating interest in the second quarter, and so on. Okay? So again, we go to this formula. We're looking for the effective annual rate. We plug in M, which is 4 for quarterly compounding, and F for one annual payment. Putting in the 20% divided by 4 periods per year, adding 1, raising it to the power of 4 divided by 1 for one frequency. Subtracting 1, we get that 20% compounded quarterly is equal to 21.55% or 21.6% rounded up. That's the effective annual rate. Okay, so you can see that we can use this formula to convert from compounding of different frequencies to an effective annual rate. Here you can see that, for example, 12% annual frequency, annual compounding frequency with one payment per year is equal to 12%. It's the same. But if you go to a semi-annual compounding, that would turn out to be an effective annual rate of 12.36%. If you go to quarterly, it turns out to be 12.55%, as we just saw. Daily turns out to be 12.75%. As you increase compounding frequency, the effective annual rate will increase. That's because of interest on interest. Okay, so now you may want to know which investment has the lower effective annual rate, something that's compounded annually or something that's compounded monthly. So right now we can't compare these two quoted rates because one has got a monthly and one has got an annual compounding. So we need to convert them both to effective annual rates. The good news is that the first one is simply because it's compounded annually, the effective rate and the quoted rate are the same, 16.5%. For number B, we have to actually divide by the number of periods, the compounding frequency, which is 12. So you see that 16% divided by 12 plus 1 raised to the power of 12 over 1 minus 1 turns out to be an effective annual rate of 17.23%. So the solution is that A is better because it is a lower effective annual rate of 16.5% relative to B, which has an effective annual rate of 17.23%. So we can use this formula to calculate the effective rate for different periods. It doesn't have to be always the effective annual rate. We could, for example, calculate an effective monthly rate. If we're given a quoted rate of 12% that has semi-annual compounding and monthly payments, okay, so we've got two different things going on here, what would be the effective monthly rate? Okay, so if the 12% is the quoted rate, semi-annual compounding means that M equals 2. Monthly payments means that there are 12 payments per year. We're looking for the effective monthly rate, so it's 12 per year. Using this formula, plugging those in, we see that now we have 12 divided by 2 plus 1 raised to the power of 2 divided by 12, because we're trying to get to monthly effective rates, minus 1. We see that the answer is 0.0097588, or just slightly less than 1% per month, 0.976% per month. Okay, so this is how much you would be charged each month. Why did we do this complicated calculation? This is how we're going to calculate the interest rate on a mortgage. We need to convert the quoted rate to semi-annual compounding with 12 monthly payments. So when calculating that mortgage payment each month, this is the rate that we're going to use. Last thing, how can you convert from one effective rate, say annual, to another, say monthly? Well, because we're converting from one effective rate to another effective rate, we can't use that formula for quoted rates. Instead, we're simply going to go back to our time value money formula, where we set two investments equal to each other, and we're going to solve for the effective rate. So, for example, what effective monthly rate is equal to an effective annual rate of 12.36%? Put differently, if you invest $1 at 12.36% for 1 year, it will grow to $1.1236. What effective monthly rate would give you that same return over the course of 1 year? Okay, now we can use our future value present value formula, and we could see that the two factors must be equal to each other. One is only compounded once per year, and one is compounded 12 times per year. You can set them equal to each other, where we put in the effective annual rate of 1.1236 to raised to the power of 1 is equal to 1 plus the effective monthly rate raised to the power of 12. We solve for that rate, and we see that the effective monthly rate is 0.978%. You will recall that this was the rate we just solved for, which is we used when calculating that effective annual rate of 12.36%. That's it. See you soon.